Hello everyone, myself P. Krishnamurthy. Today we are diving into the Radix sort. What is a Radix sort? A Radix sort is nothing but an algorithm that might just change how you think about the sorting. Unlike the basic comparison based methods, Radix sort takes digit by digit approach that might be more powerful and unique also. In the next few minutes, we'll learn the theory behind it and we can also see the step by step demonstration. We can see the implementation behind the Radix sort. You can use the logics in your own projects also. So let's get started and unravel the magic behind the Radix sort. Now, coming to the main aim of the Radix sort. Radix sort is a non-comparison based sorting. Non-comparison means what? Means it does not compare the digits in the element, but it compares the element. It sorts the number by processing individual digits. Means Radix sort is a method used to sort numbers by looking at each digit one at a time. It starts by sorting the numbers based on the small digit. What is the small digit? The small digit is also known as least significant digit and works its way up to the large digit. What is the large digit? Large digit is the most significant digit. For example, let us take a number 702. In this, the least significant digit is 2 and the most significant digit is MST 7. Then, okay, we all know the most significant digit and least significant digit. Then, how the radix sort algorithm works? Okay, let us take the example. Let us take an example that the numbers are 170, 42, and 802. These are the list of numbers. The sort works by first sorting the least significant digit. These are the least significant digits. The process is that we must sort the least significant digits first, then after the middle element. These are the middle elements. Then after the most significant digits. And the final result is stored in a list, and that is the sorted list. Coming to the main example of this sorting, here you can see the array of elements. Now we should sort these elements by the radix sort algorithm. Means here these elements are sorted based on the radix sort algorithm. How? Now we can see the total process of this sort. You can see here I have written a digit zeros on before matching the highest digit. Means here you can observe the 005. The maximum element has three digits. So I make this element also a three-digit element. Why? Because in this algorithm, we are comparing the digits, not elements. So all the elements of the digits are should be same in number. So we are interchanging the element as three-digit element or three-digit number. So now going to the main algorithm of this sort, starting with the step one. What is the step? Step one. Find the maximum element in the array. What is the maximum element in this array? 904 is the maximum element. Here you can see this is a small example. So directly we are taking the maximum element. If there is a large bunch of data in the code or in the implementation, there is a function to find the maximum element. There we can find the element so easily. Now, then coming to the step two. What is the step two? Step two is the count the total Number of digits. Max element. What is how many digits in the maximum element? 904 has exactly 3 digits. Okay. Now coming to the step 3. What is the step? Here, the step 3 is the main method because all the process of the radix sort algorithm is done in this step only. Here, we have reconstructed the array like this now. This step would be included in the step 3 only in the implementation via. Means in the regarding of the implementation, this reconstruction of the array is done in the step 3 only because with this reconstructed array only we can find the maximum element because we are considering the comparison between the digits. Okay, understood? Okay, now coming to the step 3. What is the step 3? In the step 3 there are nested steps, means there are three conditions. What are they? Let us take let them as passes. Let pass one. What is the pass one? Pass one is the comparing. See, pass one is the comparing least significant digit values. See, the pass one is the comparing the least significant values, digit values, and then sort the elements in an array by seeing only LSB values, means least significant digit values. Okay, I'll explain clearly. See, once you can see this array, compare the least significant digits. You can see 1, 6 from down to upward approach. 1, 6, 2, 4, 5, 6, 4 are the least significant digit. Compare these elements and sort the total elements in this array by those least significant digits. Means the first element will be 0, 0, 1 because by comparing the least significant digit, 1 is the lesser, means 1 is the smallest digit in the all least significant digits of the total elements in the array. Means, okay, means coming to the point, means here the least significant digits what? 4, 6, 5, 4, 2, 6, 1. From top to down approach, say 4, 6, 5, 4, 2, 6, 1 is the least significant digit. By comparing this, what is the smallest element? 1. Why we are seeing the smallest element? Because to sort. So 0, 0, 1 is the smallest element. Then next, 2 is the next element. Which element has the value as 2? 0, 7, 2. So make a note it. Then after 3 is not available. And then 4. Here 4 is present in two elements. Then we have a doubt which element should be taken first. Which element is should be taken first? The element came first into the array should be taken first. So 904 should be taken first. Then after 064, obviously. Then after 5. 5 we have one element only, so 005. And then after 6. 6 present in two elements. So 04046 is came first, right? So take it as element, first element. And then after 1, 2, 6, all the elements are reached. This step, this is the pass one. So pass one is what completed. Okay, then after pass two, what is the pass two will be discussed now. So now coming to the next step. What is the next step? Next step is the pass two. What is the pass two? Same as like the pass one. Now, uh, in past one, we have compared the least significant digits. Now we will compare the next digit. In this case, the middle element is the next digit of the least significant digit. See here, right? Compare the next element or middle in the case of this example and sort. What are the middle digits of the elements in the array? We will write to make it more easier. 0, 7, 0, 6, 0, 4, 2. Now sort these elements. Means sort these elements means these only not and the digits which are included, the elements. So sort this. Now what is the least element? 0. The elements which has the digit 0 as middle element is 3. The total count is 3. So basically we will take first element. So we will take 001 as the first element. Then after which came first, 904 came first. Then after what, 005. Okay, completed. Now after the 0, which is the next element, 2. 2 is the next element. Where is the 2? 126. 126 right in the array. Then after 4. 4 means 046. Then after 6. 6 means 064. Then after 072. Easy. This only pass 2 completed. Now coming to the next step is pass 3. Pass 3 means this is the last pass. Here we will compare the most significant digit. Sorry, compare the most significant digit and sort it. Now we will write the most significant digit. Now we could compare this array, not this. We should compare this. Okay, now what is the most significant digits in this? Maximum there are all zeros only. 0, 9, 0, 1, 0, 0, 0. All are that only. Okay, in this, which is the small element? 0 in the small element. There are so many zeros. So, which came first? We will write that 0, 0, 1. Then after 0, 0, 5. Then after which element? 0, 4, 6. Then after 0, 6, 4. Then after 0, 7, 2. Okay. Then after 1. 1 means 1, 2, 6. Then after 9, 0. Then after 9, 0, 4. See, this is the result of the past three. See, the total passes are completed. Before only I told how many passes we have to do. Means the number of digits in the maximum element. How many digits in the maximum element? 3. So 3 passes we are doing. See, once see the result is the elements are in the sorted one set. We will write by removing zeros. 1, comma 5, 46, 64, 72, sorry, 72, 126, 904. See, you can see here the elements are sorted. So the elements are sorted by radix sort algorithm. The process is completed. This is the way to find the radix sort algorithm. Means way to do the radix sort algorithm for sorting the array. So next we will see the implementation of this radix sort. Now here you can see the implementation of the radix sort algorithm. Okay, now here is a line by line explanation. First we are creating a class named as radix sort. Then after that we are initializing a function named as getMax. What does this function do? This method getMax takes an array as argument. See here you can see the int array. This is an array argument and returns the maximum value of the array and returns the maximum value. Here you can see the return max means it will take the array as input and returns the maximum element in the array. Okay, why it is needed? Because this is necessary to determine how many digits the largest number has, which defines how many iterations are needed for the sort. We know that the main theme of the algorithm is that only. Means we must know the maximum element, then after we must know the number of digits in it, then number of iterations is depending upon the number of digits. So we are finding the maximum element. Now we will go into the this function. Now first taking int max is equals to array of 0. It means initializing max to the first element of the array. This variable will hold the maximum value as the method iterates through the array. Okay, then after we will go to the loop. What will it will loop? This loop through the array starting on the second element. Since I is equals to 1 means automatically it is a second element. Second element of the if an array, if an element is greater than max. Suppose if an element is greater than the max element, then the element only is the maximum element. Suppose there are elements like 25, 30, 40. Okay, suppose we are initializing max as 25. If 30 greater than 25, then it will be the max element. Then after 40 will, if the 40 is the maximum element, then this only maximum element, right? It's 40 is greater than that element, this is only for, maximum element, right? So the it will return that finally it will return the maximum element. Next we will now you can see the next function after the maximum function is counting sort. What does this method do? This method counting sort on the array based on the digit represented by exp. What does mean exp? Exp means it is either a ones element or tens element or hundreds element or so on based on the size of the element. EXP helps isolate specific digit to sort by. Means this only. Means it may be ones element or it may be tens element. It may be hundred element. Based on the place, it will do the sorting. Next, this we will go to the inner into the loop. It takes argument array and the exp value because these are only main functions or arguments we need here. Means yes, no, yes, right. Based on the exp value only, we will do the sorting. Next, we will inner into the function. Here, int n is equals to array dot length. Stores the length of the array in n for later use. Okay, we will see it later. Now, the next line. Int output is equals to new int. It means the what is the meaning of it? Initializes an array output. The name of the array is output of the same size as array to store the sorted value temporarily. Means it is the function used to store sorted array. Nothing but the output array. Okay. Next line. Int count is equals to new int 10. Initialize a count array of size 10 to store the count of each digit. Means the count of each, it stores the count of each digit. Okay. We have understood the up to know this point. Next, here you can see a loop. What does it loop? This loop through array to calculate the count of each digit in the current place. The digit is found by this. Okay, it is iterating from 0 to the size of the array. Here we can see a line index is equals to array of I by exp percentage 10. What does it will do? It will count the index value based on the index array element and exp value, whether it is 1 or 10 or 100. And then after it will
increments the count with index value. Okay, next, here you can see the loop. Update, it means it updates the count array so that the element at count, we have the element at count holds the position of the last occurrence of the digit I in output. Means the last occurrence of the digit in output it will hold. Okay. Means suppose there is a number 202, it will holds the last number 2. It will holds the 2. You can understand here. Now the next loop. For this loop, what does it loop do? This loop do this loop through array in reverse to ensure the stability of the sorting. Means it will make the sorting more stable. Places each element in its correct position in the output array based on the count array and decreases the count of for the digit. It will see here you are counting the index value and the output value. The value is inserted at the correct index. Means according to the sort. Then after here you can see the another function. Here what it was doing, the elements in the output array is storing same into the input array. It was restoring the output array into the input array, means interchanging the name. Okay. Means it copies the sorted output array back to the input array. Updated. It will updates. Okay. Next, we will see the main method. This is the main radix sort method. What does it mean? This method radix sort sorts the array using radix sort. Okay, we understood. Next, this it will int max is equal to get max of array. It will we know that get max of the array will return the maximum element. It will store here in as max. After that, here you can see a loop. This loop through each digit place starting from the first place means exp is equals to 1. It was starting from the first and moves to higher places by multiplying exp by 10. Means we know that exp as first ones place into 10 means tens place into 10 means hundreds place. The main method is this, right? Without this, we can't do anything. And the inputs are giving into the counting sort because the total sort is depending in the counting sort. After then after we will see the main method. Now here you can see the next function after the radix sort function is print array function. This array, the main aim of this array is to print the output array. Here you can see the argument as array. For each number in the array, it will print the number. Means for every number in this array, it will print and it will show in the display. Then after the main method. The main method in which we are giving the inputs and calling the function. This is the main method. We are initializing array with these elements, and after that we are printing the original array, and after that we are calling the radix sort. The radix sort will call the counting sort. The total process is depend upon this counting sort only. Then after the output, the sorted array is printed here. This is the total aim of the radix sort and the implementation of the radix sort. Okay. Now coming to the time and space complexity of the radix sort. The time complexity of the radix sort. What is the time complexity of radix sort? Time complexity of radix sort is order of n into k. This is the time complexity of radix sort. What is the n? N is the number of elements in the array. What does mean k? K means number of digits. K means number of digits in maximum element. Okay. Now we will see the clear explanation. if any or counting sort or similar stable sort with order of n, it has the order of n time complexity. Here we have k. K means number of digits. If we are doing the same sorting with k times, then the order will be k into n because we are sorting k times. K means number of digits in the maximum time. This is the time complexity. What does mean the space complexity? The space complexity of the radix sort is order of n plus b. N means number of digits. What does mean B? The B means B is the base or the number of buckets. Don't worry about the meaning of buckets. Bucket is nothing but the example. We can see the example 10 as the 10 for decimal number, decimal digits. This is the example you can understand here. Here, the explanation of this is radix sort requires additional space to store temporary buckets for sorting numbers based on individual digit places. Here we know that the radix sort needs, suppose here the use of the radix sort, the buckets are used in this radix sort. So it needs the extra space also. Each bucket can hold up to n elements. So typically order of B is used for managing buckets and indices. So n has n space for the elements and b space for the buckets. Here is the time and space complexity. The summary of this is an order of n into k, so time complexity suitable for k number of digits is not significantly large compared to n. Means k is not large compared to n. Space complexity. Order of n plus b. Why b? B means due to buckets. Thank you for joining this in-depth walkthrough of Radixsort. We have explored how Radixsort works, its unique approach of sorting by individual digits and implemented in the Java programming language. By understanding its time and space complexity, we have seen where Radixsort fits among sorting algorithms and when to use it effectively. I hope this video has given you a clear understanding of Radixsort and its practical application. Thank you for watching. Bye.